Collaborative learning environments encourage the co-construction of knowledge in a group, a process which is correlated not only with verbal interactions, but importantly with nonverbal behaviors as well. Multimodal analytics helps identify how students interact nonverbally in conjunction with their verbal participation, providing a more holistic understanding of a student's overall participation and hence their collaboration and engagement. In this demo, we illustrate our present capabilities at detecting and tracking nonverbal behavior in student task-oriented interactions in the classroom. We demonstrate capabilities for automatically recognizing the following behaviors in a noisy and dynamic environment: pointing detection and object recognition, gaze detection and object tracking, and body posture recognition. While these are all intended to be aligned with speech recognition, we focus only on nonverbal behaviors in this video. There are two scenarios, each illustrating a distinct set of challenges to multimodal analysis. Scene 1 involves collaboration on a weights task, illustrating pointing, object detection, and gaze. Scene 2 involves a sensor immersion task while tracking engagement through gaze and posture. In Scene 1, we see 3 students working to solve the Fibonacci weights task. Pointing and gaze are indicated by colored vectors, while objects that are identified and tracked turn from red to green bounding boxes.
All right, we're supposed to weigh these blocks. Let's try this tree.
Yeah, let's do it. It looks like they're balanced, right?
Yeah, write down that they're the same weight.
Okay.
Many different modalities were used, including ambiguous linguistic expressions, pointing gestures directed at situated objects, and object tracking through gaze. The audio transcript is highly ambiguous, and gaze detection can be difficult to correct in certain configurations. Pointing detection is not vague, however, given the object model data we trained on. We're confident that with minimal training data over new domain classes, object detection can be robust over new domains. Speech is not enough. This alternative ending scene demonstrates the importance of recognizing social dynamics for determining when interventions are appropriate. You will see 2 endings where the speech transcript is exactly the same, but the body language in each is very different, demonstrating how important it is to recognize multimodal cues to determine social dynamics. These scenes demonstrate how body pose, eye gaze, and who is participating contribute to determining levels of engagement, illustrated as high, medium, and low values.
So what's the plan?
We need to come up with something that uses the sensors to help make society better.
What are we going to use, though?
I think like any of the 3 sensors could work.
Any thoughts on what we can make?
Not really, kind of just drawing a blank right now.
I think I have an idea. So we have the sound sensor, which can detect sound, and then we have a temperature sensor, which is part of the environmental. What if we use them to detect traffic in different areas? My mom's always complaining about stuff like that.
Okay, how?
Okay, so when there's traffic, it's super noisy. Cars are honking, engines are running. So we can use the sound sensor for that. Then the more cars means more heat, so we can use the environmental sensor to detect that. And they both would tell us about traffic. And if they're both giving off high numbers, that can indicate a traffic jam. And then we could do something to reroute the traffic.
As you can see, except for the speaker, the group members register as not speaking during the entire interaction, as well as showing multiple lean-outs, suggesting disengagement. Because of this, we register a change in engagement from medium to low. Now for the alternative ending.
Okay, how?
Okay, so when there's traffic, it's super noisy. Cars are honking, engines are running, so we could use the sound sensor to detect that. Then more cars means more heat, so we can use the environmental one. And they both would tell us about traffic. And then if they're both giving off high numbers, that could indicate a traffic jam, and then we could do something to reroute the traffic.
The transcript by itself correlates with 2 completely different scenarios. The first shows a student dominating a discussion as students disengage by looking at their phones, among other things. The second shows an interaction that should be left uninterrupted, where a student is talking to engaged collaborators about a solution that has stumped group progress for some time. With multimodal tracking and analysis, we can help ensure that an AI partner is intervening appropriately rather than disrupting positive collaborative group states. What you just saw demonstrates the importance of integrating nonverbal behavior recognition into the modeling and interpretation of multimodal dialogues. Only true multimodal capabilities can inform an AI partner in a collaborative real-time domain.